Well, let's go ahead and get started. Thank you all for coming. And I know some of you are new to this, but most of you were here, of course, last week. This is the second half of the senior capstone final presentations. And for those of you that haven't been here before, the basic idea behind these presentations is that students have done research in the 4 years that they've been here, or 3.5, I guess, at this point. And they've learned a lot, and they're working at a pretty sophisticated level within their discipline. But one of the challenges we have in society is how do we communicate some of these sophisticated ideas to a general public? And I think when you look at what's going on today, where people seem to have trouble with science, just as one example, but it isn't just science, it's almost any college level learning. I think part of the reason for that is maybe that we who have been through academia haven't done a good enough job of reaching out to wider audiences. When Dr. Beal and I were talking about the objectives of the course, this was something that we both felt pretty strongly was important. And so the basic idea is that the students that you'll be watching tonight have all done research within their discipline. Some have been working on their research for more than 1 year or 1 semester. Some maybe it was a paper for a seminar that they took. And they've taken that research and turned it into a presentation that they narrate, whose object is to help a general audience, people outside, beyond their discipline, to understand some of the complexity of what they studied, but also to be able to understand the basic ideas. That's a very difficult balance. And it's been made more difficult for them because they have 6 minutes and 40 seconds to do it. They have 20 slides in which they can speak 20 seconds each. They get a bonus slide for showing their references because we think it is important to give credit to academic sources, and in some cases to a lot of sources of photographs and things. And so in 6 minutes and 40 seconds, you're going to hear about, I think, 12 or 13 presentations tonight. Could be off. I think that's about right. And these are all been pre-recorded. And at the end of each of those, the presenter will be, who's here, will actually speak live with some sort of reflection about what this was for them, what they learned from it, or what they learned more about their own subject matter, what they would have liked to have talked about that they couldn't talk about because of the complexity of this topic. And if they want, they have the opportunity to allow a question. And that's about all we're going to be able to fit in time-wise. So any questions? Dr. Beal, you want to say anything before we begin? Nope. Okay, so we'll start with the first presentation, and they will all be played consecutively. And hopefully this is all going to work. I'm going to share my screen. I think this will work. Okay, I think everybody sees a screen with a bug near the top left. Okay, so that will be the one to start us with. Is everybody still seeing the screen?
Hello, my name is Allison Bundy, and I'm doing my presentation over the research that I've done at Lions since 2019 under the direction of Dr. Alan Dodd, entitled Macroinvertebrate Communities Along a Gradient of Poultry Houses. So I would like to start talking about water. 3% of all of Earth's water is fresh water, the kind that humans drink. And even then, only 5% of all of Earth's water is accessible to us, which means that we need to protect what water we have. So that begs the question, well, what could pollute our waters? An obvious one that comes to mind would be industrial waste, which is a big problem. But another one a lot of people don't think about is agricultural waste. We have pesticides, we have fertilizer, and we also have poop. So cows, chickens specifically, produce a lot of poop. And we have seen chicken houses like these pop up across Arkansas within the past few years, specifically in the northeast part of the state, which Lyon is located. So what effects do these chicken houses have on our streams? Well, there's a lot of ways we can measure that. One of them being chemically, how much phosphate and nitrogen is in the water, how much heavy metals are in the water. We can also look at genetic mutations in crayfish to determine if there is any change in water genetically through the organisms. What I do is I look at sentinel species. So a sentinel species is like the canary in the mine. Historically, miners would bring down canaries, and so when there was noxious gas, the canary would stop singing and die, which would let the miners know that they need to get out soon or else they would be next. So how do we use sentinel species in our streams? Well, different species are pollution tolerant and some are pollution intolerant. So those pollution intolerant species are not going to live in streams that have a lot of pollution in them. That means I can go and look at the different bugs in the stream and determine if they are or not pollution tolerant. So some examples is I specifically look for what's called the EPT taxa, which are mayflies, stoneflies, and caddisflies. And if they're in the water, they're pollution intolerant. That means that water is pretty clean. So how I do this is I take the net that you can see my friend Jordan Webb has, and I stick it into my stream and have the water flow through it. I then do something called the bug dance. So with that net in the stream, I kick up all the rocks and the dirt around in the mud right in front of the net, so all my little invertebrates will flow into the net. Next, I take all of that dirt, bugs, rocks, and I put them into the pan that you can see on the screen. I sift through the pan, take out some big rocks and leaves, and put them into a jar, preserve them for later. I do this 3 times at every stream, and we have 12 streams. Next, when I get back to the lab, I will dump all of those samples that I have out, and I will individually pick out every single invertebrate I see. So snails, the little bugs, crayfish, all of them. I then work on identifying them under a microscope. And so as I identify them all the way down to family, and then I count them. Sometimes I'll have 2 snails. Sometimes I'll have over 1,000 fly larvae. So it's really a toss-up depending on what stream I get. But this information is very important because this tells us, one, the diversity of the stream, or how many different kinds of bugs do we have living in the water. It also tells us the abundance. So how many bugs do we have in our water? So we looked at poultry houses. We picked streams that had different poultry house densities. So the different streams had different amounts of poultry houses around them. And in a minute, you'll see a map pop up. And so this is important because this can tell us, does a high number of density of poultry houses affect the macroinvertebrate community in those streams? And so you can see on the map in front of you, we have all the triangles are our streams, and then all the red dots are the poultry houses. And so a lot of these poultry houses are new and built within the last 4 years. So this graph in front of you has the poultry house densities with their relative abundance of the different kinds of bugs. If you remember, I said the EPT taxa was very important, which is the red line. We expect the red line to go down with the higher amount of poultry houses. But it doesn't in this graph. Weird, right? We thought so too. So upon further investigation, it doesn't have so much to do with the density, doesn't really matter how many are in an area poultry houses are. What really matters is how close those poultry houses are to the stream. So if a poultry house is closer to the stream and it rains, the chicken poop goes into your water. So cool, we know this. You know your water can be gross, but what does this mean? Well, this means that we can give lawmakers the information they need to make proper water quality laws. So, for example, Arkansas is very interested into this because, as you know, with Tyson, we are very involved in the chicken production. Tyson is in a lawsuit with Oklahoma because Oklahoma's streams have been destroyed because of this chicken houses. And so Arkansas lawmakers need to ensure that Arkansas water quality stays top notch. So, in conclusion, next time you take a glass of cold water from the tap, make sure you raise one to our little bug friends who help ensure your water quality in your local streams. Thank you.
Hello. Thank you all very much. My biggest challenge with all of this was definitely actually recording it was my hardest part, just because normally when I give presentations, I'm able to like feed off of other people around me, or maybe if I say a funny joke, I can stay on that high for a little bit. So sticking to a regimented recording was difficult for me. I want to say big shout out to Dr. Dodd and all of our labs for giving me the ability to do this research. I absolutely love it. And then my capstone group. I feel like we worked really well together and my presentation would not have been what it was without them. So with that, I can answer any questions anybody might have if we have time.
Nobody has questions? I do. I have one question then.
Yes.
How can you say the stream is clean if it's got all those bugs in it?
Well, they're supposed to be there. You don't want to just like drink pool water all the time. So it's all part of like the ecosystem, right? So everything has to be in balance, and that includes all the animals that that live in those habitats.
Okay, thanks.
Allison, can I ask you just to, you may have said this, and I mean, somehow I missed it, but you mentioned that those EPT taxa are mayflies, stoneflies, and caddisflies. First, can you tell us why they're called EPT taxa? And second, can you maybe tell everybody where they may have encountered these insects before? Because some folks may be familiar with them and not know it.
Sure. So the mayfly, stonefly, and caddisfly are what we call the EPT taxa, because Dr. Dodd's gonna make me say these names out loud. The Amifera, the Plodoctera, and like the Trichoptera. So those are like the big fancy science names for these little doodads, little bugs that we have. As like they are, I mean, they're just mayflies and stoneflies. If you see them flying around, they kind of hang around where you would expect water to be because they're just like living. Is that what you wanted, Dr. Dodd?
I was just, like sometimes people fly fish with them.
Oh, yeah. The stoneflies. It's a big fly fishing bait to use at the end when you fly fish. Yes.
Okay, I think we need to move along. Thank you. So let's go on to the next presentation.
Hi, my name is Miranda Lamb, and my research topic is about opioids, specifically their biological interaction with your body. But I didn't want to just give you a lecture. So instead, I want to tell you about a story where you are the main character. Imagine this. You are a college athlete, you love your sport, and you have a very promising career ahead of you. But one night, on your way to a big game, an accident occurs. You never saw it coming, no one did. but it happens all in the blink of an eye. All you see is darkness. You aren't sure what happened, but you don't feel any pain. It's kind of peaceful, actually. It's a bit of a relief from the stress you've started to feel since finals started. What is that sound, though? That buzzing sound? It's so annoying that it wakes you up from that deep abyss. As soon as you open your eyes, you see the big fluorescent light above you, the source of the annoying buzzing sound. And then you notice the white, hot pain that seems to be everywhere, your neck, your spine, your legs. And then you remember the accident, the bright headlights, and the sound of crushing metal. A doctor comes through the door right at that moment. She's happy you're awake, and she asks if you remember what happened to you. You only remember that you were in an accident. She tells you that you were in pretty bad shape when you came in, and it took surgery to fix you up. Because of that trauma, she's going to prescribe you a pretty strong painkiller. You tell her that you're in so much pain that you can't really think straight at the moment. She rounds your bed to an IV bag that you hadn't noticed before. She pushes a button, and you start to feel a bit drowsy, but the pain subsides. It's morphine, she tells you. It is very similar to the medicine that she will prescribe for you to use at home. It will help you to cope with the pain as you recover, but you have to be careful because it can become highly addictive if you use it improperly. That sounds really intimidating, so you ask her for a better explanation of these drugs. Opioids, she calls them, very strong painkillers that use opium, a natural extract found in opium poppies. It is a chemical that can be helpful for coping with pain because of the way that it mimics endorphins, which are your body's natural pain-tempering hormones such as adrenaline and noradrenaline. She explains that your brain has tiny opioid receptors. Endorphins like adrenaline bind to them and activate them. This releases dopamine, or the happy hormone, and helps to block pain signals. Opioids bind to these receptors more tightly and hold on longer. Because of this, they can be used to treat more severe pain. Well, that doesn't sound so bad. What's wrong with being so happy that you can't even feel pain? That doesn't sound dangerous to you at all, but she assures you that it can be. Not because of the happiness per se, but because those receptors also help to regulate many of your normal bodily functions. Those receptors also regulate noradrenaline levels. Noradrenaline is a hormone that influences your heart, lungs, and even your digestive system. It stimulates these for normal functions such as breathing, digestion, blood pressure, and heart rate. Opioids suppress the levels of noradrenaline, and a large dose can actually lower breathing and heart rate significantly. You assure her that you'll strictly abide by the dosage guidelines, but that's not all that she's worried about. She reminds you to only use the medication when you need it because consistent use over long periods of time can force your body to develop a tolerance. This can actually lead to dependence for normal day-to-day functioning. Your body learns to tolerate this imbalance of necessary hormones in two different ways. Your body may start to remove opioid receptors, or these receptors may simply become less responsive. Either way, this leads to your body needing a higher dosage of the medication in order to experience the same effects. You tell her that if you find yourself taking too much, too often, you'll just stop. That's the easiest way, after all. You'll just have to buck up and deal with the pain. But she pleads for you to not do that. You can make yourself really sick, she says. But how, you wonder? When your body learns to tolerate the effects of opioids, it becomes highly sensitive to lower concentrations of suppressed hormones in your body, such as noradrenaline. If a dependent person stops taking their medication abruptly, this new balance that the body has adjusted to is turned upside down. An opioid-dependent person will soon experience withdrawal symptoms after stopping their medication. Different drugs cause slightly different withdrawal symptoms, but opioid withdrawal is usually characterized by anxiety, vomiting, sweating, elevated heart and breathing rate, and even insomnia. These withdrawal symptoms can become so extreme or uncomfortable that people choose to use illicit drugs rather than to face them. Many people turn to these illicit drugs because they are cheaper and easier to access. She tells you that 80% of heroin abusers actually became addicted to prescription opioids first. You thank the doctor for her patience and willingness to explain everything to you. She assures you that she would rather have you ask questions and be aware of the consequences instead of accidentally finding yourself in a preventable situation. She makes sure you don't have any more questions before she leaves to allow you to make arrangements for going home. As you pick up your prescription at the pharmacy, you wonder how such a powerful and dangerous substance can be contained in such a tiny pill. If that doctor had not taken the time to break it down and make sure you understood the danger of not being careful, you could have been blindsided by an awful situation. Over the course of several months, you take special care to monitor your intake of that medication. You make a pretty quick recovery, and though your body will always bear the scars and a little bit of discomfort, you soon return to doing exactly what you love to do.
So the biggest problem for me was also learning or figuring out how to record it. But then again, I also had to go through several laptops because I broke the screen on it. And then I actually rented a laptop, but the left side of the keyboard didn't work, so I couldn't use it. And then I borrowed my mom's laptop, but her hard drive was too full, so it wouldn't let me record anything or do anything. And then I borrowed another laptop, and their hard drive was too full, so I wound up having to just get an external monitor and hook it up. And another problem that I really faced was getting the right amount of science to like narrative ratio, because I made a first draft of this, and it was actually based on a seminar that I did in organic chemistry. And organic chemistry, it's as scary as it sounds, I guess. And at first I had a really hard time breaking it down. So then when Dr. Dodd talked to us about making it into a story, it's like a light just kind of went off, and I was like, yeah, I'll do that. And then the problem that I ran into was it was so much of a narrative that it had none of the research in it. So I had to kind of rein myself back in again and start over. And I had 4 or 5 drafts of it on paper before I ever actually put it into a presentation.
Any questions for Miranda?
If you've gotten more time, would you talk about how the opioid crisis tends to affect the South more than the North?
If I would have had more time, possibly, because to be honest, that's honestly what I studied to get all the information. But I don't know if you can really tell that because of the fact that I had to kind of draw it back so much because there's so much science involved in it. And I didn't want, like I said, I was so afraid that it was going to turn into a lecture, and I really, really didn't want to do that. So I probably would have had I had more time, but yeah, I definitely didn't have enough time for that.
Okay, great. Thank you, Miranda. Let us go on to the next presentation.
Hello, my name is John Pruden, and today I will be introducing you to the idea of computational chemistry using a simple counting theorem known as Pauli's method. Now, I don't expect you to leave today with a perfect understanding of the vast field of computational chemistry, but I hope instead to show how mathematics and chemistry can influence and improve one another. Now, in chemistry, we deal with elements that combine with one another to create compounds. These can be as simple as 2 hydrogens combining with 1 oxygen to make water, or as complicated as a lengthy, multi-step reaction to create an organic molecule. In any case, we want to be certain that our end product is what we want, meaning that it has both the elements and the structure that we desire. Now, we can represent these reactions in a number of ways. You may remember writing reactions like this in high school chemistry, showing the elements as letters but neglecting their three-dimensional structure. But as molecules get larger, the structure of a molecule becomes more important in defining its properties. Molecules with different structures may be more or less stable, for example. Now, this new representation of the same reaction given before provides some structure for each reactant, or individual starting component of the reaction. But now we're left with a question. What will the structure of the end product be? Could this reaction create multiple products with different structures? And if so, how many possibilities are there? It turns out, yes, molecules can have the same number and types of elements while being different in structure. This is so common, chemists created a name for them: isomers. Iso meaning equal, mers meaning molecules. You can have many different kinds of isomers, but don't worry about memorizing them. Just know that any given isomer can have very different chemical and physical properties from one another. Now, there are isomers that vary in their basic carbon structure, like this one, and there are isomers with the same carbon structure but a different location for key elements, like this one. This second kind of isomer, a stereoisomer, varies across a central component of the molecule, like a double bond or a ring. This is the kind of isomer that we will look at today. Now, as a molecule gets larger, its structure becomes more variable and thus more important in defining the molecule's properties. Even a simple molecule like C5H10 can have dozens of isomers, and since different isomers of the same molecule may have different properties, chemists can either use these differences for our benefit or watch out for potentially dangerous interactions. So it's important to know about every isomer possible. The thalidomide tragedy, which anyone from a Grafton class will remember, is a perfect example. Thalidomide was a drug with one isomer that was considered a wonder drug for morning sickness and another isomer that caused birth defects in children. Because of the lack of testing related to the second isomer, it was blocked by the US FDA, but thousands of children in Europe still suffered from these birth defects. So, knowing that isomers are important, let's look at a common example. We might change a molecule to make it more stable or more reactive, and a common change we want for a molecule is called fluorination, or the addition of a fluorine element to a molecule. The reaction I showed before is an example, the fluorination of cyclopropane. If we want to know what products this reaction can create, we need to look at all the possibilities. Frequently, chemists would simply draw every possibility, but now this is where Polya's method comes in. First, we assign an arbitrary number to each reaction site. In this case, a fluorine can replace a hydrogen on any location of this molecule, so we assign numbers like this. We then asked ourselves, hypothetically, how could we move this molecule in such a way that the end result looks like it did before we moved it? It's important to note that we're not actually moving a molecule, but rather using this as a thought experiment. This is how chemists think about the idea of molecular symmetry, how similar the regions of a molecule are facing each other or around an axis. Well, first, we could do nothing, and the end state of this molecule would be the same as when we started. Secondly, we could rotate this molecule by 120 degrees, shown by this simple depiction. If we were looking at our real molecule, hydrogen 1 would move to position 3, and then position 5, and then back to position 1, which we can write in this form, 1, 3, 5. We could also rotate this molecule 180 degrees, shown with this simple depiction with the triangular molecule flipping over. Now looking at the full molecule, hydrogen 1 would move to position 2 and then back to position 1, which we can write the same way as before, 1, 2. And these pseudo movements are called symmetry operations, and they define the symmetry of the molecule. We end up representing these pseudo movements in a fancy notation called cycle notation. For cyclopropane, using the known symmetry operations, we end up with this chart. On the left we have the operations, in the middle we have the cycles, and on the right we have the cycle notation. This represents how many positions one hydrogen can cycle through before returning to its original position, and we can see the ones we discussed highlighted. The fun thing about cycle notation is that now we can use this to find a polynomial that represents the number of positions each element can cycle through according to that symmetry operation. So if, for example, we were fluorinating the molecule, we would have two kinds of elements, hydrogen and fluorine, represented as A plus B, and we would substitute this for that X. We then replace X with A plus B for each different symmetry operation and sum the resulting polynomials, which gives us this final polynomial telling us what isomers are possible for any combination of hydrogen and fluorine. So if, for example, we had 5 hydrogens and 1 fluorine, there's only one molecule, but 4 hydrogens and 2 fluorines gives us 3 possibilities. Using that polynomial, we now know that there's one molecule that uses all hydrogens, one molecule if you have one fluorine, and there's also 3 isomers if you have 2 fluorines, and 3 isomers for 3 fluorines. And this is important because we may not have drawn every possible isomer on our first pass, but now we have a way to make sure we were right. As a research tool, Polya's method can be helpful in what's called combinatorial chemistry. Chemists will model thousands of molecules, frequently various isomers, reacting with other molecules that the chemist wants to target. Finding out the number of isomers of a molecule in advance may lead chemists to selecting a better molecule to create more isometric possibilities, leading to more diverse and efficient drug discovery. Polya is also very relevant as a teaching skill. Polya's method may be used to find the number of isomers of a molecule, and then students can be asked to draw these isomers or create them with molecular modeling software. By teaching students with a computational method, we can hopefully create a generation of digital native chemists that intuitively understand computational chemistry and may be more able to exploit this process. Here are my citations. That's my presentation. I'd like to thank Dr. Burt for mentoring me on this project, Dr. Buby for running this course and helping me pare down my presentation to fit time, and our many external speakers for providing advice. Now it's time for future John to answer questions. Hello, I just turned on my camera. Can everyone see me? I'm gonna take that resounding silence as a
Yes, we can, John. We can
yes.
see you.
Okay. Cool. Thank you. All right. So as far as my meta reflection goes, this was definitely a difficult project to pare down to 6 minutes and change. I think the most difficult thing is that the mathematics and the chemistry of it all is very high level and theoretical. So it's hard to show how that will ever touch your life. I think Dr. Schwanke has said it best, where he says that work in pure mathematics is done now so that usefulness can be found 100 years later, because that's typically how things go. But it was definitely enjoyable to try to challenge myself by paring this down. And I think I ended up with a product that gets at least something to everybody. I don't think everybody made it to the end, but I think more people made it to the end than I could have expected when I started this. So that's kind of where I'm at. And then as far as this course goes, I wish I knew how to animate. That was the biggest takeaway from making this. If I could have figured out how to animate molecules, I think my presentation would have been so much better, but I don't have the software or the time to learn to do that. And then any questions?
For John?
So I'm still working a little bit on how to word it, but you said that you would take one conformation of the molecule and then turn it into a different conformation? It's like if you had 3 fluorines, you would change the orientation to be something else?
So in what step are you referring specifically? Like whenever we're drawing the isomers at the very end? Or so whenever?
Earlier on, you said that you could have 3 possible, like if you had 3 fluorines and 3 hydrogens, then there were 3 possible orientations?
Yes.
So were you like actually like having one and then physically changing it into another, or is it just a thought experiment?
No, yeah, it's 100% just a thought experiment. So all that Polya's method can do is tell you the number of isomers possible with a given atomic makeup. So all Polya's method did there was tell us, okay, if you have 3 fluorines and 3 hydrogens, you have 3 possible molecules. And you saw that there's the one with 2 fluorines on the same carbon, and then cis and trans substitutions. So with cyclopropane, which is a relatively, thank you, Dr. Burt just told me, their names are 1, 2 cis, 1, 2 trans, and then 1, 1. What was I saying? The thing that Polya's method tells you is how many isomers there are, not specifically what they are. Which is why I brought up combinatorial chemistry, because knowing how many isomers there are of a given molecule is helpful for that. But then as a teaching tool, you're able to
then go in and try to figure out what all of the isomers are, knowing how many you should end up with. It's kind of a check for understanding.
Okay, that's good. We need to move on to the next presentation, please. Thank you, John.
Sherlock Holmes is a cultural icon whom we consider to embody all things clever. To reference him is to make an allusion to logic and mystery. Time and time again, he has been reincarnated in literature and film alike. He is, without a doubt, your typical character of Detective Sleuth, bolstering a rich history of cultural relevance. Okay, but the main point here is that Sherlock Holmes is old. We see him almost everywhere in our media, but most of us don't know much about him beyond the outfit, logic puzzles, and British accent. Something even the most snobbish of die-hard fans forget is that the Sherlock novels included a lot of human-animal relationships, which brings us to our sort of general thesis. When you examine the human-animal relationships in Sherlock Holmes, it shifts the foundation of his character. Now, to understand the shift, we have to understand the roots of Sherlock Holmes. He was created by Arthur Conan Doyle during the Victorian era, which serves as its own archetype for all things posh and English. Besides drinking tea and dying from cholera, Victorian England also had a fascination with oddities. They developed an oddity culture, which collected and curated anything from taxidermy pets to shrunken baby heads. Victorian oddity culture could be the subject of a full-on anthropological study, which, while probably infinitely interesting, is not the subject of this Kucha. So, for our purposes, we can think of oddity culture as a sociological version of Freudian psychology. Freud wasn't English, and he only started his research at the tail end of the Victorian era. However, his theories developed the same way oddity culture did. That is, through obsessing over the unfamiliar unknown and turning into tabloid fodder. As long as we're borrowing the Freudian analogy, we should also consider what he thought about animals. One of his most famous studies, Wolfman, suggested that a man's nightmare about wolves was connected to his fear of being punished for incestuous thoughts. While oddity culture did include some avenues of incest, the thing we should focus on here is that animals were supposed to represent our subconscious. This meant Victorians read from the perspective of archetypical symbolism instead of mythological symbolism. The difference is that the mythological symbolism leads the reader to think of, say, an owl as a representation of wisdom. Meanwhile, archetypical symbolism leads the reader to think of that same owl as a drive to achieve wisdom. Psychology, while mostly pseudo, was becoming an intrinsic part of the reading process. Which makes a lot of sense when you think of the big picture behind the Victorian era. This is when the English were going through their Industrial Revolution, as well as launching multiple colonialist invasions. They wanted to make sense of society which devalued them as factory cogs, but also hailed them as a superior race, creating a double-edged sword in which Englishmen either died in the slums or condemned entire continents to the same fate. So, to bring everything back together, Sherlock Holmes is not just a detective sleuth, but a reflection of England's psyche as it conquers its domestic land through industrialism and foreign lands through colonialism. This reflection is best captured in Sherlock Holmes' relationship with both domestic and foreign animals, hence the focus on human-animal relationships within the Sherlock Holmes canon. Perhaps the most well-known human-animal relationship within the Sherlock Holmes canon is between Sherlock Holmes and Toby the dog. While often reincarnated as a bloodhound, Toby was actually a mutt. He first debuted in The Sign of Four, and he was described as an ugly, long-haired, locked-eared creature, half spaniel and half lurcher, brown and white in color, with a very clumsy, waddling gait. Toby helped Sherlock Holmes solve the mystery of the leak by acting as a bloodhound. But this relationship between Sherlock Holmes and a domestic animal reveals both the superficial and dependency factor. Toby is judged as a mangy mutt despite being vitally important, similarly to how the English judge each other as proper and improper based off arbitrary measures of lineage and etiquette, despite the proper relying on the improper for their services. As for foreign animals, Sherlock Holmes has a short relationship with a venomous snake. In the adventures of the Speckled Band, Sherlock Holmes eventually finds the cruel Dr. Grimsby Roylott, who was well known for abusing anyone and anything around him, planning to kill his nieces by dangling a speckled band over their bed. When he finally finds it, Sherlock Holmes cries, "It is Swamp Adder, the deadly snake in India." Sherlock, of course, saves the day, sparing at least one Dr. Grimsby Roylott's nieces from his murder plot. While the speckled band had little agency of its own, unlike Toby, who was the prevailing hero of his tale, this reveals the colonist factor of this human-animal relationship. This animal, which was specified as Indian, was no more than a tool for Englishmen, similarly to how many non-English people were seen, especially those of color. Then there's the Hound of Baxtersville, which, of course, features the Hound of Baxterville, a hound described to be a great big beast with the same prowess of demons. According to Sherlock's latest client, the hound is part of a curse that has been plaguing his families for generations, ever since a distant relative had led a Moor woman to her death. Sherlock, of course, reveals that the hound, while real, is not the product of the curse. In reality, it was a pet that had been sicked on the supposedly cursed family, killing them from fright. This human-animal relationship further emphasizes the superficiality of England, as the hound was considered otherworldly for fitting outside the expectations of a typical dog, similarly to how many people within England were outcast as deviants of society for mild-mannered things. Flipping back to Dr. Grimsby Roylott in The Adventure of the Speckled Band, he also has a cheetah and baboon, which wander freely over his grounds and are feared by villagers almost as much as their master. While meant to act as security, they are mainly strange sights for Sherlock Holmes as he launches his investigation. While these human-animal relationships carry the same colorless factors as the one between Dr. Grimsby Roylott and his speckled band, since the cheetah and baboon are his tools, it also carries the secondary factor of isolation and exploitation. Dr. Grimsby Roylott not only removes these animals from their native lands, he also uses them as a form of spectacle, similarly to how most natives were ousted from their lands and then treated as New World wonders. There are many, many other examples from the Sherlock Holmes canon, although many of them go down a more metaphorical route, like the panhandler and the man with a twisted lip, who is repeatedly referred to as Bulldog to emphasize the weariness of his character, or Tonga in the Sinophore, a man from the Andaman Islands that is repeatedly referred to as a half-beast in increasingly racist ways, but the pattern has already been established. Sherlock Holmes will interact with both domestic and foreign animals in ways which reflect how the English interacted with its domestic and foreign lands. While the domestic animals carry the burdens of both a superficial and taxing society they are guaranteed a place in it, whereas all things foreign are a dangerous spectacle, either a threat to society or an accessory to it. But this is where we wrap things up. When you examine the human-animal relationships in Sherlock Holmes, it shifts the foundation of his character. Sherlock Holmes becomes less your typical detective sleuth and more like a dialogue piece between the many facets that made up the Victorian era, mainly its conquering of its domestic lands through industrialism and its conquering of foreign lands through colonialism. One can only imagine what else modern-day readers might discover about Sherlock Holmes or other well-established characters when we look into the nit and grit of their stories.
Okay, Zoe, you have some reflections?
So I kind of almost regret basing this off an English paper, if only because my advisor, Dr. Robbins, had kind of warned me. The basis of English is to kind of take the inconsequential and make it consequential. Like for I almost said Dr. Beebe. In Dr. Beale's class, I once wrote like a 5-page paper about how a character hadn't talked for a page. So it was very difficult to make something without it was just difficult getting out of the English major mindset because I needed to provide multiple examples and I just needed to kind of give an overview of why it was an example instead of diving into the deep dark secrets of whatever a period placement might mean. So it was just like a lot of kind of toiling within myself to be like, no, this isn't an English major paper. It's a presentation for the general population. You just have to do it this way. Other than that, there's just a lot of issues with recording. I have a pretty bad speech impediment, so I had to kind of play with the audio a lot. But oh well, we're done. Any questions?
Yeah, I've got a question. I think as far as this depiction dealing with English colonialism and industrialism and everything, do you think that has started to get a little bit more toned down in later representations, especially the more recent movies with Johnny Depp and stuff? Do you think that's kind of been toned down for modern day audiences?
So I'm not super familiar with the newer incarnations with Sherlock Holmes, which maybe I should be given the fact that I did a whole project on it, but okay, sera. I will say, just because of the way Victorian society tends to be kind of watered down in modern depictions, because I kind of had the remark in my presentation where I was like, oh, it's all being posh in English. People tend to kind of look over the class issues unless it's a setup for some Star Wars romantic issue. So I think it's not really toned down so much as just ignored. But I don't know if that's a good answer.
Yeah, totally.
Other than that, it was awkward to hear myself, but I'm glad I did it, and I'm sort of proud of myself.
Okay, thank you, Zoe. Let's move on to the next presentation.
Hello, my name is Carson Matthews, and today, for my exploration of Dionysus and democracy, I sought to answer two questions. Can a relationship with theater change people's relationship to society? And how does one's relationship to theater and society influence democracy and democratic citizenship? Theater creates truth from the collision of ideas, from conflict. Democracy relies on truth to function as an extension of the needs and wants of the people, and the ability to present stories on stage allows for numerous and diverse conflicts, yielding more truth. We are required, as an audience, to empathize with these stories, to entertain the theatrical collision of ideas in order to engage with and enjoy a performance. Similarly, democracy requires us to empathize with opposing viewpoints in order for political discourse to be productive. Theater is deeply entrenched in our society and creates a space for common community, for our differences to be identified, interpreted, and questioned, for experiences to be shared, all of which create a more informed, understanding foundation for democracy by the inclusive people, for the inclusive people. Theater is a mirror held to the society it is born from, and in the face of an unsuccessful or failing democracy, like in authoritarian systems, theater will suffer as well. Empathy and the sense of common community are broken down, and artistic expression is driven underground. Common community under theater, as we know it, began in ancient Greece. The city Dionysia was established as an annual festival in celebration of Dionysus. It brought together Athenian tribes that were previously at war and united them with religious ritual and performances of dramatic tragedies. Dramatic tragedies, for a play to be a tragedy, people have to suffer, but they suffer to teach us something. Tragedies presented at the city Dionysia were essentially a Greek chorus standing on stage wearing debatably creepy masks and warning you that if you try to escape fate, well, we all know what happened to Oedipus, don't we? And so we start out having all kinds of fun with the all-knowing Greek chorus, and then Thespis, the first thespian, the first actor, he steps out from the chorus and he talks back to them, and in this moment, theater is changed forever. He has created dialogue, dissenting viewpoints. And all of a sudden, there's a foil to the homogenized Greek chorus. Instead of this unitary authority imparting knowledge, the audience must engage through the conflict. There is a push and pull that we must participate in, an exchanging of ideas that we must entertain. And, well, to summarize just a little bit, successful theatricality and strong democratic citizenship have three things in common: the belief that truth comes from conflict, that it is not the possession of any one person, group, or entity, the use of frequent widespread empathy, and the sharing of experiences to bridge gaps in understanding. 2,500 years after Grecian theater latched itself to the idea of democracy, Joe Patt created Free Shakespeare in the Park under the democratic idea that the best art we can produce should be universally attainable. And he continued to unwaveringly support this free and open sharing of knowledge in an artistic setting for all to partake in. This leads Pat and his theater community to the notion that for this democratic circle to be complete, sharing knowledge isn't enough. We have to share these experiences. So he created the public theater, where people could do so and could be afforded the same empathy that they had given to others that they had seen on the stage. They could get their own piece of the action. And at this intersection of the ideas of knowing yourself, what you agree with, disagree with, stand for or against, and sharing yourself, your experiences, your stories, that's where we find the unity and the understanding and the visibility that characterize strong democracy and strong theatricality. Unfortunately, in our democracy, there are still those that are unable to share themselves, whose stories are silenced. That is where theater comes in. The voices of the unheard are elevated into verse, into art, consequently elevating those who the voices belong to and amplifying the reach of a narrative possibly previously unheard. For example, Pat's Public Theater premiered the play For Colored Girls Who Have Considered Suicide When the Rainbow Is Enough by Ntozake Shange, which amplified the stories of Black women and Black girls and changed our dialogue surrounding this previously ignored group of people and the experiences that they have in common. And continuing with this influence on dialogue, The Normal Heart, Larry Kramer's play about the rise of HIV and AIDS in the 80s, premiered at the Public Theater in 1985. And the New York Times review of the play had more information about AIDS than the New York Times had published in the previous 4 years. It's absolutely mind-boggling. And taking that, my questions back from the beginning, can a relationship with theater change people's relationships to society? Short answer, I think absolutely. There's that common community. And how does that theater-society relationship affect democracy and democratic citizenship? Well, society, like theater and democracy, is made up of interactions and relationships between people, and the quality of those interactions and relationships is reflected in the quality of our theatrical and political spaces. Theater and democracy are bound through and upheld by the ways that we intermingle with each other. So, what do I want you to take away from this? Well, do not shy away from conflict. Instead, seek for how it can teach and please. Overuse empathy and use it to build inclusivity, and then use that inclusion, whether you're at the polls or on the stage, so that we can all have our voice. Thank you very much.
Well, thank you everyone for giving me your attention for my 6.5 minutes. I think as far as this project goes, the thing that I ran into is kind of taking a research project that deals with something that is an influence of kind of like a mass of people. I think a lot of my peers do a lot of scientific research that's looking towards the future, whereas I was kind of analyzing the past and kind of how it influences us today. And I just really wanted to kind of make it make sense and make people kind of understand how all of these things intersect a little bit more than maybe we think. So difficult and fun at the same time.
Questions for Carson?
So do you consider the dialogue that theater offers to be handicapped at all by the fact that theater tends to be over-commercialized and the ticket's way too expensive for anybody to ever buy?
Yeah, I think actually in my research about free Shakespeare in the Park is that they did run into that problem, that they became some of the most coveted tickets. And I think that's the charge to sort of continue theater, especially in like smaller and local settings, is because of that belief that everyone should have access to this and be able to tell their stories and see other people's stories. So I think that sometimes it can be, absolutely. And I think that's kind of the role of smaller scale operations, like traveling tropes, especially, and things like that to combat that sort of thing, hopefully.
Okay. Well, let's move on to the next presentation then. Thank you, Carson.
Hello and welcome. Today I will be talking to you about the impact of poultry house pollution on our local watersheds and why we should be concerned about it. I'm your host for tonight, Victoria Prater-Rochier, and I could not have done this presentation of my research without the help of Dr. Alan Dodd and Dr. Paul Beebe. So without further ado, let's talk about chicken poop soup. Before we get started, I wanted to break down some terms that I will be using throughout our time together. Eutrophication is a fancy word for out-of-control algal growth in water. This can be detrimental to water life, as we will see in a minute. Interflow is the term ecologists use to describe the movement of water underground and laterally. Think back to grade school science. You know water is recycled through a process of evaporation, condensation, and precipitation. Of course, it's a little more complex than that, but we'll skip the nitty-gritty and focus on one detail, interflow. As rain soaks into the ground, it grabs nutrients along the way and joins the interflow system. This interflow system can have a great impact on nutrient distribution in larger water systems. Water systems like streams have a wide variety of organisms, things like bacteria, bugs, fish, and plants. A healthy stream system has a good balance of these organisms, aka stream equilibrium. An unhealthy stream system has an imbalance where one organism has dominated the stream's resources. This is an example of a healthy stream. So how do we get an unhealthy stream? One way to cultivate an unhealthy stream is to expose it to nutrient-rich substances like chicken poop. Chicken poop is high in nitrogen and phosphorus, and when it is introduced into a stream, the stream sees a boom in plant life. Nutrients is necessary for proper stream health, but remember, equilibrium equals a healthy stream. When excess nutrients is introduced into a stream, algae proliferate and grow. Their expedited growth rate can be disastrous for a healthy stream, however. Algae suck the oxygen out of the water, and more algae means less oxygen for other organisms. The other organisms will die off, and the stream will be deemed unhealthy. So why do we care about chicken houses that provide us with delicious fried chicken? Well, it's not the fried chicken that's concerning, it's the other products of chicken rearing that we should be concerned about. Chickens poop between 11 to 15 times a day, and it's high in nutrients. Improper storage of chicken poop can lead to nutrients seeping into the interflow system and collecting in larger bodies of water. Okay, so that was a lot of information that I just threw at you. So here is a mandatory brain break. Did you know that chicken poop can be made into a moisturizing lip balm? I mean, at least there's one use for that nutrient-dense litter. I'll let you decide whether that is a good investment or not, but your brain break's over now. Poultry houses are popping up all over the country to meet our ever-growing population's food demands. These aren't your cute little hutches that you built with grandma and grandpa. No, these are industrial-sized warehouses that hold up to 20,000 chickens each. One warehouse produces 2.5 million pounds of chicken poop a year. That's a lot of waste for one warehouse, and usually houses are clustered on a farm. To see how this clustering of poultry houses impacted water quality, Dr. Dodd and our research team set out to find answers. On this map, the red dots represent poultry house locations, and the green triangles are streams we sampled from. As you move south, you see an increase in poultry house clustering, so this was the perfect way to see how poultry houses impacted local stream systems. Looking at the phosphorus levels in streams we tested, there was a correlation between phosphorus and poultry house density. As poultry house density increased, phosphorus levels within the streams increased. Our two outliers, Tennessee and Hubble, had extremely high phosphorus levels in a low-density location. These two had houses directly upstream from our sites, leading us to believe that proximity may also play a role in stream health. As water quality declines and algae take over with excess phosphorus from chicken poop, the food web is impacted. Stream bugs and fish die, their deaths mean less food for larger predators, so they die, and the chain continues up the web until the whole thing either collapses or the animals adapt. But this could potentially disrupt other food webs. Streams are part of a larger system, and they feed into rivers leading to the Gulf. By feeding into other systems, the unhealthy streams carry their phosphorus-rich poop water into previously healthy streams and infect them. We can actually see this collecting nutrients in the Gulf of Mexico's dead zone. Here, eutrophication is rampant and organisms cannot survive within it. Eutrophication also impacts our drinking water. Excess algae is troublesome for water treatment. It clogs up the machines, increases disinfectant demand, makes the water taste and smell funny, and much more. The chances of pathogenic exposure increase with high levels of algae. The toxins produced by eutrophication and using excess disinfectants increases the risks of cancer. I know all of that was scary to learn and think about, but it is important to acknowledge that our food needs are negatively impacting our overall health indirectly. By increasing poultry houses, we effectively increase food production, increase phosphorus in groundwater, increase eutrophication, and increase negative impacts on food webs and essentially our health overall. But food is necessary for survival. So what is the solution here? And is there even a viable one? What can we do so that we can keep food production up while minimizing the effects of poop produced by soon-to-be chicken tendies? Honestly, there is no easy solution to our question here today. Currently, there are a few federal and state regulations that chicken farmers must abide by. They must adhere to the protective rates of chicken poop fertilizer application and conduct soil tests. If an area has been deemed at risk for overnutrification, farmers are required to adopt and abide by a nutrient management plan. Poultry houses have to have approved poop storage facilities and proper irrigation as well. These rules and regulations aren't enough, however. We need to focus on clustered poultry houses because our data shows that house density can impact phosphorus levels within a stream. We should also look closer at limiting poultry house proximity to streams, as we suspect that a vegetative buffer benefits stream health. We also need to hold chicken farmers more accountable when they fail to meet federal and state regulations. In the end, we know that poultry houses are impacting water quality in our own backyard. When stream health declines because chicken poop seeped into it and caused an algal bloom, the impacts are greater than some fish dying off. We risk disrupting complex food webs in our own health. So the moral of the story? Don't let the chicken cross the stream. Thank you for listening to my Pecha Kucha on the impacts of chicken poop and water quality. Of course, none of this would have been possible without Dr. Dodd, Dr. Beauty, and all of these wonderful resources. If you have any questions, please feel free to email me at victoria.praterrochier@lyon.edu. Thank you.
Hi, so I'm going to apologize for my dog snoring in the background. I don't know if you can hear it, but she's really loud. But I mostly struggled with condensing the information. I wanted to talk so much more about what we had done, but I couldn't. And I also wanted to kind of, emphasize the importance of what research that we're actually doing. I'm just a bio major, so I'm a little biased, but I get excited about these things because it is extremely important. So I guess I wanted to kind of convey that to you all too. So that's all I had. Do you guys have any questions?
I'm sure Dr. Dodd has a question.
Okay, put me on blast. Yeah, so I really don't actually. what was your favorite part of all this?
Well, my favorite part and the part that took the longest was making all of the animations and like all of the little pictures.
Yeah. Did you make the eutrophic, mesotrophic, oligotrophic? Did you make those?
Yeah, I mean, yeah.
That's amazing. I was like, these conceptual diagrams, I was curious about that actually because they were really good. I was like, I thought they were little pictures you'd gotten from somewhere. And then as I was looking at them, I was like, oh my gosh, did she make?
Yeah. Yeah, they took a lot of time. Like I was actually surprised at how much time those took. Just because I'm a perfectionist, so it's just like I need it to be right. Thank you.
Great, thank you, Victoria. So let's move on to the next presentation.
Hello, my name is Kyle Rose, and the title of this presentation is Pythagorean Theorem and Order Theory. This presentation will cover some of the research that I, Dr. Schwanke, and Zachary Ward have done. Instead of just jumping straight into the research, I thought it'd be interesting to take a look at the Greek mathematician himself, Pythagoras. Pythagoras was born in the 6th century BC and is known for many things, one being his philosophy, Pythagoreanism. Not gonna lie, it seems a bit cultish, like they believed in beans being taboo and, drowning people to disprove core parts of the philosophy. But the other thing that Pythagoras is most known for is his mathematics. Seen here is a high school geometry student's worst nightmare, the Pythagorean theorem. This theorem simply states that if you have a right triangle, then the sum of the squares of the two shorter sides, A and B, is equal to the square of the longest side, C, or the hypotenuse. Now, there are a good amount of current day applications of the Pythagorean theorem, including construction, gardening, and navigation problems such like this one. Using the Pythagorean theorem, we can calculate the length of C Street using the lengths of A and B Street, which in this case, C Street is 2.5 miles long. But what if there was another way to do this? To answer my rhetorical question, yes. We are able to prove that this long string of letters and curly braces is equivalent to the Pythagorean theorem. Now, I won't be going over the proof we came up with, for it's way too long and complicated. Instead, I'll break this equation into easy to understand pieces, and then bring them all together at the end. To do this, though, we must first talk about functions. Functions are like relationships. In a good relationship, when you put stuff in, you get something in return. If you don't get anything out of it, then it's a bad relationship, meaning it's not a function. There are many interesting things about functions, but for this presentation, we're going to focus solely on order theory, or infimum and supremum of a function. We generally call the infimum the greatest lower bound, but we can also think of it as the absolute minimum, or the smallest number possible of a function. As an example, take this function here. The infimum, or absolute minimum, is 1, because with any number you plug in, the smallest number you get in return is 1. In addition, we have the supremum, or the least upper bound. We can think of this as the absolute maximum of a function. Looking at the examples, we can see that sometimes a supremum or infimum may be infinite, because no absolute maximum or minimum exists. The concept of infimum and supremum are important to us for two main reasons, one being something called the geometric mean. Now, you may be familiar with the arithmetic mean of two numbers, A and B. It's where we add A and B and then divide by 2. However, the geometric mean of two numbers, A and B, is just the square root of A times B. What's really cool about this particular geometric mean is that it has been shown that this is equal to the infimum of the function f of x is equal to ax over 2 plus b over 2x. I don't have time for an extensive proof showing it's true, but how about a simple example as proof? In this example, we have the square root of 9, which is just 3. However, with slight manipulation, we can rewrite it as the square root of 3 times 3. Using the geometric mean, we get an infimum that when graphed, we can see that the absolute minimum or infimum of it is 3, which is the same as the square root of 9. This probably looks pretty trivial, but this step is perhaps the most important part of our research and of this presentation. Doing some very simple but important algebraic manipulation, we can rewrite the length of a side of a triangle, in this case A, as an infimum using the geometric mean. The other reason for using infimum and supremum is with the square root of a squared plus b squared. It has been shown that this square root is equal to the supremum of the function f of x is equal to a cosine x plus b sine of x. Yet, again, I don't have time for an extensive proof, so why not another example? In this case, we have the square root of 25, which is just 5. Knowing my Pythagorean triples, I can rewrite 25 as the sum of 3 squared plus 4 squared. Using our new supremum, we can graph the function and see that the absolute max, or supremum, is 5, which is equal to the square root of 25. Now, through some nifty math magic or algebra, we can derive the equation I had shown a long time ago from the Pythagorean theorem we have all come to know and love. What's interesting and important to note here is that the square roots are gone. Now, if you don't trust me and believe what we have is true, how about an example to show you otherwise? Going back to the navigation problem we did as chart of this presentation, we can use our new equation to calculate C again, which should be 2.5. To start us off, we plug in our A and B, or the lengths of A and B Street, and simplify a bit to attain the supremum. Instead of dealing with the supremum directly, let us deal with the infimums first. Graphing the two functions inside the infimums, we find the first infimum to be 2 and the second infimum to be 1.5, which makes sense when looking at how we derive these infimums in the first place. Now then, we take these values and plug them into the supremum and attain a new function. Graphing the function, we are able to see that the absolute max, or supremum, of the function is 2.5, which is the same as the c we calculated a long while back. Of course, this took a little more effort to calculate the answer than how we did it before, but there is merit to this new equation. I may be showing off a little with this, but here's the more advanced version of the equation we have derived previously. Yet again, no square roots to be seen. This lack of square roots makes our equation stronger and better than the previous Pythagorean theorem, because our equation holds in more general settings where the old Pythagorean theorem will most likely fail. Now, like Pythagoras, we don't know what future applications this new equation could be used for. That's just the nature of pure math research. What I can tell you, though, to end on a positive note, is that someday in the future, some mathematician will stumble upon this and find a real application that can impact our lives for the better, just like what has happened for Pythagoras and his theorem. Thank you.
Alrighty. Yeah, that was my presentation. It was really challenging. Going to start off with that. Really, really challenging presentation to make. This was a kind of a new experience for Dr. Schwanke and I, and having to simplify things or generalize things, math, that's at a high level for people with, a low amount of math knowledge or low interest in it, whilst trying to stay accurate with our research. Found to be very, very challenging. Went through several different presentations. Talked to Dr. Buby a couple times. Bless Dr. Buby, because explaining an old presentation was an experience, I have to say. Yeah, I learned a lot though. Trying to get to talk to people and trying to relay math knowledge to a more general audience. Any questions?
I have one really quick question.
Yes.
I know for like my project, I had to jettison a lot of stuff. I guess, what is one thing you had to get rid of that you think was like the coolest thing?
I mean, there's originally before the presentation I had up to like the last minute talked about vectors and talked about the norm, which is the length of a vector. And we talked about the inner product. And that stuff is really cool. That's where like a lot of the, research is vector spaces, vector classes, stuff like that. And not having to be able to talk about vectors, because vectors can be pretty advanced for someone that, may have just taken college algebra, several years ago. I wish I was able to talk about it, but I feel like what I talked about here, talking about functions, and in theorem and supremum, the most important part, concept, I'm still happy.
Cool, thank you.
No problem.
Kyle, can you expand this to higher dimensions?
Yes.
So
yes, that's the main thing about the Pythagorean, this our research, is that it generalizes it to more abstract settings, as I usually put it. The example we did with SCARP was we took matrices and into 4D vectors, I think. So that's higher dimension right there.
So is there a relationship to Fermat's last theorem?
I have no clue what that is, to be honest.
Okay. I don't know. You can talk to Schwanke about it maybe. So Fermat says if there's no a to the n plus b to the n equals c to the n, there are no solutions to that.
Okay.
And he wrote a little margin note in a research notebook that says, and I have a proof for this. And nobody's.
Oh, yes. Yeah, and there was, yeah. I'm not sure if that could be helpful. It's always a question to ask, right? That's what research is you ask a question and you see if you can prove it or not. Yeah, as Dr. Schwank said, no relation with it.
Okay, I think we need to move on to the next. Thanks, Kyle.
Hey guys, my name is Seth, and through my Pichakucha, I hope to demonstrate to you the importance of being financially literate. Take a second and try to think, what connects virtually every job in the world today? The answer is money, which makes it all the more puzzling that 76% of millennials, that's us, lack basic financial knowledge. Due to this shocking fact, I'm calling an emergency meeting. Guys, I promise you, you do not have to be Warren Buffett to make your money work for you. As we approach the end of our undergraduate careers, we need to understand the importance of staying on top of our financials now so we can reap the benefits later. Now, before I jump into my recommendations, let me address why you should listen to me. Well, aside from the fact that I'm a double major in business administration and economics, the following avenues of investing are recommended as safe and consistent ways to obtain wealth by successful investing companies like Vanguard and TD Ameritrade, websites such as Investopedia. Now let's begin very simply by defining investing. Investing is buying assets or resources with economic value like bonds or stocks that you believe will grow in value in the future. And if you're wondering, a stock is merely a share of ownership in a company, and a bond is like an IOU given to you in exchange for money now. And after its expiration, you'll be compensated for your money plus a little extra, which is specified interest. Now, these are just two small ways you can invest. Most people invest in accounts that are very diverse or full of a lot of different kinds of assets because it lessens the risk that they lose money. On average, a diverse portfolio of assets will earn about 6 to 8% yearly compounded interest. Now, this might seem like a lot, but a compounding interest rate of 7% takes just over 10 years to double. It's not that long. Now, as you'll see in the next graphic, saving early and saving often can far exceed what someone who saves more later could do due to this compounding interest. For example, if you saved $150,000 from 25 to 40, by the time you're 65, you could be a millionaire, as opposed to saving later where you would not reach the same heights. So how do you do this? What kind of accounts do you use? What's the plan? Well, before I jump into the two main types of retirement accounts, we first need to remember that life is messy and things like, I don't know, a global pandemic can hit overnight. Too soon? Sorry. But really though, it's true, and most people aren't prepared for any level of emergency. For example, 40% of Americans don't have enough cash on hand to cover a $400 emergency. When that cost rises to $1,000, 61% of Americans would be unable to afford it and would go into debt. That's not even a major emergency. So, to begin, you should start an emergency fund with $500 with the aim to hit $500 in the event that you blow a tire or drop your computer and need it repaired. As you enter into your professional life, that number should increase accordingly. And realistically, you should look to have 6 to 10 months of expenses saved up in case you were to lose your job. Once you have this done, you can begin looking to the future. As simple as it seems to know you need to save for retirement, on average, in 2013, 56 to 61-year-olds only had $17,000 total saved up for retirement. That's less than a year's tuition at Lyon, guys. So, how can we do better? Well, we're going to examine the two most popular types of retirement accounts. Those are the 401k, which is a company-sponsored retirement account plan, and the Roth IRA, which is a retirement savings account. I know these names sound complicated, so I'll break each one down individually. With a 401k, this is job-based. So once you get your first job, you're likely to be offered a 401k or something similar. Now, as I said, this is simply a long-term investing plan that you can use, which has replaced things like pensions of old. Now, 401ks usually consist of a combination of assets like bonds and stocks. And the primary benefit of such an account is that usually the company will match a certain amount, around 4.3% on average, of your income that you put in. So they will offer you up to 4.3% of free money from your income if you match that same amount. And the second advantage is the money you put in the account is taken out of your salary before tax. This means you'll be taxed less since your income is technically reduced in the short term. Now, on the other hand is the Roth IRA. As I said previously, this is simply another kind of individual retirement account. However, it's not company sponsored, and therefore a Roth IRA can be opened with virtually any financial institution. They're particularly advantageous to young people like us because the money put into that account is already taxed. So and you take it out later, there is no tax. Additionally, Roths generally give you more freedom in your investment options. And finally, this account has what is called no minimum distribution, which means after you retire, you're not required to take out a certain amount every single month. So how do you take advantage of both of these options? Well, I call it the hamburger method, though that's not the official term. But as you can see, if you invest in your 401k up to your company's match, then go over to your IRA and max out your contribution to that, and return any remaining money to your 401k, you will be maximizing the benefits you can receive from both accounts. Now, these are by no means the only ways to invest, but they are some of the safest. So to recap, you need an emergency fund. You should check out 401k or similar options depending on your field, and you should look into a Roth IRA. Now, in conclusion, I encourage you to do your own research and really invest in yourself by becoming financially literate. There are a ton of free resources available to you, and the earlier you start, the better off you'll be. Because the truth is, financial problems are not fixed with money, but by becoming financially educated. So I encourage you to invest in you.
Hey guys, so wow, was it a relief to finally get that recording correct? I think at the end of that, my throat was patchy, I was out of water, and actually in the last little references page, I mentioned my email address again, but somehow I managed to mess up my line email, which is actually just my own name, so I had to remove that because that was just too embarrassing. The one correction I'd like to make is that in the beginning of my Picha Kucha, I pointed out that 76% of millennials are financially illiterate, which is true. However, that is not technically our generation. We're Generation Z, or at least most of us are, which I actually find scarier because millennials are technically already in the real world and they have no clue how to handle their money. So that's pretty terrifying. But as many others have stated in this reflection period, it's very challenging to dumb down something that you're very passionate about to just the basics. And at times I did feel like I was leaving a lot out. As I said at the end of that presentation, these are by no means the only ways you can invest. They're just some of the most simple, especially for us as we enter a professional field and get our first jobs. And the last thing I want to say is, unlike many of my classmates, the goal of my presentation was not to teach you as much as to encourage you to teach yourself. Because the reality is there's numerous ways to save, and what's best for me may not be what's best for you. I just hope that you start saving as soon as possible.
Any questions for Seth? Okay, thank you, Seth.
Hello, my name is Zach Hodge, and my research is THC and CBD hero from villain. For this research, it's from my last summer's medicinal chemistry course, and my advisor for this project was Dr. Bert Hollingsworth. For my research in this class, I wanted to focus on controversial or unexpected sources of medications for various treatments. This is marijuana, or cannabis, and first I want to give you a brief history of it as a medication, then discuss recent history and the negative stigmas associated with it. Next, discuss the research being done, and finally, tell you why it's actually an important medicinal research topic. As early as 2900 BC, there's a reference to cannabis as a medication. This is a picture of Emperor Fu Si, who is credited with bringing civilization to China. He's also supposedly referenced cannabis as a medication with both yin and yang. And this idea continued in China and other cultures independently. Ancient societies such as Greece, Egypt, and India all reference the same different medicinal uses of cannabis. Historians even believe that Jesus used cannabis-infused oil for anointing based on the descriptions in the Bible, and the use of cannabis continued well past the Middle Ages all over the world into modern times. Its use was so widespread that settlers even brought cannabis with them to the Americas when colonizing. The most famous colonies in United States history, such as Jamestown, were also famous for their cannabis exports. And everyone knows about the founding fathers, but not everyone knows that they were also cannabis growers and users. In 1850, cannabis was added to the United States Pharmacopoeia, which is a big list of all the accepted drugs in the country. Then in 1906, the Food and Drug Act forced labels on all medications, including cannabis, but this was a negative turning point because in 1911, Massachusetts became the first state to outlaw cannabis, and the trend continued. As the federal government tightened its grip on cannabis, Samuel Caldwell became the first person to be convicted for selling cannabis. More laws were passed, and it was soon moved from the Pharmacopoeia. There was a split, though, where some reported cannabis's benefits and the others reported it as a terrible drug with no medical uses. Restrictions kept getting tighter on cannabis, and in 1936, the Bureau of Narcotics urged for full control of cannabis by the federal government. More propaganda like films was released until in 1970, with the war on drugs, cannabis was completely demonized and disregarded as a viable medication. One thing that did come out of the war on drugs was the drug scheduling system. It ranks drugs from 1 to 5, where 1 is highly abusable and has no acceptable medical uses, and 5 is being the least likely to be abused. Cannabis got put in Schedule 1 right next to heroin, LSD, and ecstasy, discrediting the long history of cannabis medications. Now that I've explained the climate behind the research, I want to get into the details of what is being done, and to do that, I need to explain receptors briefly. Basically, only certain molecules will interact with certain receptors to produce a response in the body. But this is a very important thing for drug development, because in a medication, if it can't interact with its target, it's useless. The receptors we're interested in are CB1 and CB2, and together they make the endocannabinoid system. These receptors are dispersed all over the body, but a large amount are focused on the central nervous system. These receptors have impact on several neurological disorders, as well as signaling in other systems all over the body. A big part of developing medications is structure-activity relationships, and this diagram shows how that would be used to assign activity to regions of a molecule and look at how they interact with the receptors. By changing these regions slightly, the medication can create a slightly different response in the patient's body and form a better medication. To start altering and improving the medication, we have to have a starting point, and that starting point is pure THC. You can get that by either making it in a lab or extracting it from a plant, and one of the most common ways of extracting it is by sifting it through smaller and smaller screens as seen in the diagram, but it tends to be less pure in this way. This is THC, and it's the primary ingredient in all cannabis medications. And I want to draw your attention to the 2 sections that the arrows are pointing to, because these are the regions that we focus on altering thanks to our structure-activity relationships. And for a medication, THC leaves the body rather quickly, but while it's in the body, it has some drastic side effects. THC is psychoactive, which means that it alters your brain slightly when it's in your body, and this effect is the high that you feel when smoking cannabis, but can go more extreme into paranoia and anxiety. You want to alter the molecule in the regions I pointed out previously to reduce these effects, but keep the medicinal benefits, and this makes it a more viable medication. This drug is Kesamet, and it's made by altering natural THC in the regions highlighted with the arrows. These small changes actually make the drug more likely to interact with the receptors and drastically minimize any psychoactive effects. It's used to treat nausea and vomiting from chemotherapy patients, and many other drugs use similar techniques. Sativix gets around the psychoactive effects of THC in a different way. It uses a mixture of THC and CBD, as seen on the right, to counteract the psychoactive effect rather than modifying THC itself. CBD actually counteracts many of the negative effects of THC when proportioned correctly. And this medication is used to treat multiple sclerosis and severe cancer pains. CBD is a really interesting substance because while it comes from cannabis and has many of its own health benefits, it's not actually a controlled substance in the US. And this means that we can get lots of CBD products like lotions, oils, and e-cigarettes easily without having to worry about regulations. Now let's say that there's a patient with a severe condition that either can't or doesn't want to use more extreme medications such as opioids. Cannabis-based medications allow a gentler and less addictive option for these patients. Putting yourself in the shoes of these patients, being your loved one, you can quickly see why this research is useful. Another reason this research is so important is because it gives us another option for treatment. Some medications don't work as expected for some patients, and these cannabis-based medications give us another opportunity to treat them. By creating these medications, it allows more diverse options to treat people and give them what they deserve. Here are my references, and thank you very much.
So the hardest thing for me for sure was technology. I learned to never trust my computer ever again. It fought me literally every step of the way. But other than that, it was fairly smooth. Dr. Burt and Dr. Buby helped me like scale it down a little bit. There were a few things that I wanted to get into just because I really like chemistry, but they really didn't fit for this format, so I didn't get into them. But if anyone has any questions, then I'll answer those now.
Hey, Zach, this is cool. Can you speak a little bit about, CBD is really taken off. You can just find it everywhere, right?
Yeah.
You go to the gas station and they're selling stuff with CBD in it. So I'm wondering, in your research, did you learn anything about, information about how people can learn the most helpful dosages, because it's not really regulated right now very heavily, and also, how can you tell, well, can I just give an example? So I take CBD oil because it's the only thing that helps my back pain. And I've taken some oils that took the pain away. And it's like, great. But when I first started out, the first couple that I bought were these different brands, and they didn't do anything. So could you also speak to that, like how there can be some issues with quality?
Yeah, definitely. So as far as dosage goes, CBD and THC both are really simple for dosage or for dosing, because the only system that these molecules affect are your endocannabinoid system. And so you literally can't, you can overdose, but you can't have any like serious side effects from overdosing. Like if you overdose on THC, you get paranoid and anxious and like mostly bad emotions. But if you wait a little while, then it goes away. And CBD is honestly really similar. So it just kind of doubles down on the effects that you have. If you take more, so you'll feel a more intense calm with CBD, because CBD is actually an antagonist in your body. So there's not really an issue with dosing. Most people will put a dose so that you can sort of feel it, but it's not too extreme, because some people do get uncomfortable. It kind of makes you veg out. It's the part where you just kind of want to lay down and not do anything. As far as like not getting an effect, that would be probably from like doping it with things, or like having really low amounts in it, but they're probably marking it up because it is so popular that you can get away with that and there's no regulations on it. So it's more of just a substance that you can do anything with.
Thank you.
I think we're over time for the questions, so let's go ahead and move on to the next presentation.
Thank you all for coming tonight. My name is Melissa Elliott, and the title of my presentation is Where Should Huckleberry Finn Sit in My Classroom? I would like to give a special thank you to Dr. Crosby, who has helped me so much through this entire process. It really has been a great adventure creating this work for you all. So, one of the biggest complaints with Huckleberry Finn is the use of the N-word. Mark Twain uses the word so much in the book it is hard to find a page without it. What is widely argued is whether Twain uses the word to show the abuse that daily the enslaved African Americans went through during the time period and to show the dialect of the time period, or whether he uses it as an assertion of his own privilege as a white man and his ability to use the term. Another huge complaint is that any time that Jim has to make a decision or has to be saved, it's done by Huck. Rather than relying on his own faculties as an adult male, Jim is instead saved by Huck. When Jim is captured, when Jim sets out on the adventure at all, Huck is right there making the decisions and pushing the plot. One of these decisions is to go south rather than to go north. Jim, as a grown man, should have understood that the trek north into Canada would have ensured his freedom rather than the trek south into deeper slave territory, which proves that this decision is mostly an adventure tale for Huck rather than a true tale of freedom for Jim. Jim, at the ending, even gives up his own freedom to save the boy. Because Tom, one of Huck's friends, has been injured, Jim goes into town to fetch a doctor rather than running to free himself, and is in the end only freed by a loophole in the will of his deceased master at the time. So the reason this book became so ingrained in the American convention and the American literary canon is that at the time of the Civil War and the Reconstruction, America was struggling to find its footing on the world stage as not only a military power, but as an artistic power. We were quickly rushing things into the canon to be sure that we had the same prestige and artistic power as our European neighbors. The same is true of the South, especially after the Civil War and when we were rediscovering Southern texts. We quickly found that a lot of those texts were racist, and we were able to shove that aside purely because the South wanted these texts that they could cling to and call them Southern pride and say, look at the work we had done, look at the art. Twain himself is certainly an artist of his time. His writing is incredible. He lectured extensively, and a large portion of his work was satire work in which he pointed out the major flaws in the society he had grown up with by making fun in a very serious manner during these lectures in high art periods. Twain himself was actually quite the activist when fighting for the rights of African Americans and in the abolition movement. He even paid out of his own pocket for several African American students to attend higher education. He also worked with trying to better the lives of Asian American immigrants, Native Americans, and the early feminist movements. Now, when modern Americans, especially high school students, read Huckleberry Finn, it is easy to misread, not as the satire it is, as the scathing review of the awful treatment of African Americans and the perspective of the white people of the time on these African Americans, but as a lauding of this, as a praising that using the N-word is meant to be acceptable to these students, which is why when we teach that, we have to be very careful that our students understand that. And if we choose to teach Huckleberry Finn, we have to be sure and do it in the right way so it is sensitive and educational in the right way, rather than being misread and mislabeled. This is why we must very much focus on historical context. When reading Huckleberry Finn in the historical context of Twain as a famous satirist, it is easy to see that Twain is actually writing a scathing review and saying, look how you see Jim. Jim is a grown man, but Huck treats him like a child over and over and over again. Now, one of the ways which we look to solve this more easily than actually functionally is by taking out the N-word altogether, giving students redacted copies. But when we do this, all we do is we take out the singular word in that dialect and give them a book that is still chocked full of these examples of racism and maltreatment of enslaved African American people. When we teach this book in the South, it is a fine line we tread between making sure we praise the work of Mark Twain, the literary creativity and beautiful scope of the Southern dialect and Southern world, without praising that racism of the time, showing our students that that is inappropriate and we cannot function like that any longer. When we teach Huckleberry Finn outside of the Southern United States, we must be sure that we tell our students, or show our students, that they are not free of this burden either. Students in the North especially might be tempted to say, oh, well, I wouldn't have done that. We were a free state. I never would have been racist. But in the historical context, if you had lived in that period, you likely still would have been. Now, another big part of this is the view of the community. If you live in a community that's very active in your school and takes a very active participating role, they're going to have a lot of opinions. And in a more progressive community, they may be accepting to these hard topics and having these hard discussions. But some communities are so steadfast to older ideas that they may be uncomfortable with that. This is also true with parents. Parents especially want to protect their children and make sure their children are in a happy, healthy community. And so a lot of times parents will try to protect their children by not allowing them to have these hard discussions that turn them into well-educated and more informed adults to make their own decisions once the parents can no longer be as actively involved. When we teach this, if we teach this, we must also be very aware of our individual students. When teaching this, if you have, say, 1 or 2 African-American students in a largely Caucasian classroom, one should take the time to make sure that student is comfortable with discussing these topics, or if they might need an alternative assignment, because this book can be very hard for certain students. This also plays into your class makeup. How many students are African American? How many students are Caucasian? How many students are neither of those things? No matter what classroom you have, your classroom is going to be diverse in some way, shape, or form. And as a teacher, we have a responsibility to cater our lessons to that classroom, whether that be largely African American or Caucasian. But that is not the only dichotomy. There are also Asian American students, Native American students, Eastern European students. When we teach students diversity and historicism, we need to be aware of their biases and what can most help them grow. Does Huck Finn actually serve the purpose we want for our students, or should we even look at another text? Thank you so much for your time, and I hope you enjoyed my presentation.
So thank you guys for coming and listening to that mess, also known as my audition to be an auctioneer, because I had to talk so fast. So the two things that if I could go back and change that I would absolutely change about this presentation is, one, I completely forgot to add my email, but I will go into where Dr. Buby is publishing it on YouTube and comment my email, because that is very important that they be able to reach us should they have questions. And also that with this form, it's very difficult to be as cautious as we should be of the nuance of these situations, especially when dealing with relationships of our students and their opinions and views on race and how we should teach that in the school system. It's a very nuanced discussion, and being able to choose the right words and explain exactly what you mean is very important, and that's not exactly an option when you have so little time. So that was a little terrifying, but if anybody has any questions, I would love to take them.
I have one quick question. Are your citations meant to make a point about redaction?
No, I just have that many citations. Since this is actually a full-length research paper, the ones in white are the citations for the paper, and then the ones in blue are for the photographs. I promise they're there. I promise they're real. They're just very hard to read.
Okay. Thank you, Melissa. We'll go ahead and move on.
Hi, I'm Ben Smith. And today I'm going to be talking about stream health and how statistics can help us see what is going on in stream ecosystems, as well as devise strategies to mitigate harmful effects on these ecosystems. In this process, I have a brief overview of the multiple linear regression and how it is used to identify relationships that explain the data we collect on site. To get us started, I'll start with a story. You walk up on a stream similar to the one pictured. On the surface, it looks like it's perfectly healthy. Sure, maybe it's not perfectly clear, but the water is mostly transparent with some mossy rocks scattered in the stream. Unseen to the blind eye, though, there can be many things going on that seriously affect the health of the stream and the organisms that rely on it to survive. For example, nitrogen levels in the stream could be too high, then causing excessive plant growth. When plants in the stream die, their decay process uses a lot of oxygen, thereby reducing the oxygen supply to the stream and potentially causing the death of many other organisms in the stream that require oxygen to live, such as our little fish here. That's where our research question comes in. What factors might be affecting these streams that we can't see? Are there some outside factors influencing the stream's health that we could work to reduce in order to maintain the beauty of the streams that we see? As a result of this question, we turned our focus to a prominent industry here in Arkansas, the poultry industry. Chicken houses are a prominent source of nitrogen and phosphorus due to the large amounts of chicken litter produced by the chickens. Chicken litter is commonly used as fertilizer due to its high nitrogen and phosphorus levels. When it rains, however, this nutrient-rich litter washes into nearby streams over time. Our research centers on the effects that this runoff has on local streams. In order to explore the effects of chicken litter on local streams, I used the data collected by Allison and Victoria as part of their research and began to analyze it. After a little bit of data entry, which ended up being fairly tedious, and organization in Excel, I was ready to start investigating some of the causes of what we were seeing in the stream data. The first step in analyzing a research question is deciding what tests to use. There are a lot of statistical tests out there, but for this particular research question, we have many things that can cause a response in the environment we are looking at, so it makes a lot of sense for us to use a multivariate test. We also want to use a regression, which allows us to find relationships between the variables. Combining both of these things, we decided on a multiple linear regression. Before I get into analyzing our results, though, I want to give a quick overview of what exactly a multiple linear regression is. Here we have a generic scatter plot, and we need to find the line of best fit. The process of finding the line of best fit gives us a linear equation of the form y equals mx plus b. This equation is a relationship that we can use to predict the effects of a predictor x on a response variable, y. The main difference between a simple linear regression, like the one on the previous slide, and a multiple linear regression is the fact that in a multiple linear regression we are testing the effect of multiple predictors, or x's, on the same response, y. This makes graphing the multiple linear regression much harder than graphing a normal simple linear regression, so we rely on software that does that for us. Since we are choosing multiple predictors, or x's, it's very helpful to have a way to organize the different sets of predictors for each response. In order to do this effectively, I use an approach that uses models that are scored based on their accuracy according to the multiple linear regression. All in all, I came up with 15 models to test, 5 models for each of the 3 response variables I chose. For my response variables, I chose the concentrations of nitrate, soluble reactive phosphorus, and chlorophyll A in the water. Nitrate is essential for plant growth and can be found in fertilizers, manure, and also rises from rainfall. Phosphorus is very similar and can also be found in manure and fertilizer as well. Chlorophyll A is a pigment used in photosynthesis and gives an image of plant life in the stream. My predictors varied for each response variable, and each model was scored relative to each other model in the response group. In the chlorophyll A group, 3 models were significant, with one accounting for over 40% of the variation in our data, and the other accounting for almost 70% of the variation. In these models, we found significant relationships between 2 predictors and the response. The first of these significant relationships is between chicken house proximity and the response, chlorophyll A. Following the example that I gave earlier, the connection between these 2 factors is clear. The nitrogen and phosphorus from the chicken litter runs off into the stream when it rains, causing increased plant growth, thereby increasing the amount of chlorophyll A in the water, as chlorophyll A is involved in photosynthesis. As for the second predictor-response relationship, it's a little more nuanced. The predictor for this relationship is discharge, or the rate at which water leaves the stream system. It varies based on several factors, such as width, depth, and the speed at which the water is moving in the stream. When discharge is low, this causes the water to pool, allowing nutrients collected there to be easier taken up by the plants, increasing chlorophyll A levels. As a result of both of these relationships, plant growth is increasing. Although this doesn't sound like too bad of a thing on the surface, as I described earlier, increased plant growth can lead to decreased oxygen levels if it gets out of hand, which will in turn start to cause the death of organisms that require oxygen to live. The lack of oxygen is catastrophic to the stream ecosystem, and it can take a long time to recover, if at all. There are a few outlying things that are unclear with our data, however. The chicken house proximity showed no relationship with nitrate or phosphorus concentration. This could be due to a multitude of factors. I have chosen the wrong group of predictors to highlight the effects of chicken house proximity on nitrate and phosphorus concentration. There could also be environmental factors that I didn't consider. For example, the data I analyzed was collected over the summer months where there is typically less rainfall. This reduces the amount of nitrate and phosphorus leaching into the water, and the low rainfall also serves to lower discharge, promoting plant growth and thereby increasing the chlorophyll A concentration. In order to further explore these effects, extending the time frame of our measurements would help to further establish the relationships we found. Despite these outlying factors, we were able to show that a relationship between chicken houses and chlorophyll A does exist. This discovery allows us to develop strategies to mitigate the impact that chicken houses have on our local streams. For example, regulations that ensure that chicken houses are not placed within certain distance of stream are helpful, as well as the planting of trees and other plants that reduce the amount of runoff getting into streams. If we employ these strategies based on the trends that we see in the data, we can be confident that we can maintain our local streams not just for our lifetime, but even in the lifetimes of our children and grandchildren. We as humans have had a huge impact on the Earth as we've used its resources throughout our history, and we need to be aware of just how much damage we can cause, taking steps to maintain the Earth's health where we can. Here are some of the references used to create this presentation. I want to thank Dr. Dodd for giving me the opportunity to work with her on this project for my honors contract, as well as for agreeing to work with me this semester on this presentation. I also want to thank Dr. Buby for taking the time to teach us about public scholarship during this course, as well as offer suggestions for improving each and every one of our individual presentations as we made our way through the course. Lastly, I want to thank you all for listening. Hope you enjoyed. Hey, thanks for listening to my presentation. I didn't listen to it myself because I hate hearing myself talk. So, a few things just about this class. It was really enlightening to me to find out a lot of the ways, a lot of the ways in which I could improve
how I relay information that could be considered complicated to people outside of the statistics discipline and the biology discipline. That was very challenging. Meeting with Dr. Buby and discussing those things with him and trying to explain them was really helpful, and devising a way to be able to explain complicated things, and then also trying to fit within the confines of the 20-second per slide restriction was also very, very helpful, but also very challenging. If there are any questions, I could take those now.
Ben, I don't think I've ever asked you this. How did you come up with your models?
I just took what I knew from ecology, which I was taking that semester that we did I took the semester before we did the project, I guess, because I was taking biostat. And I just tried to think of what effects the chicken manure could have on the environment based on what we did in ecology.
Thank you.
Okay, thank you, Ben. We'll go ahead and do the next presentation.
Hey everyone, today I'll be talking about the emergence of the British opium trade in the 19th century and its impact on the Qing Empire in China. It's a fascinating tale involving smuggling, war, and lots of drugs, but my research focuses mainly on the economic side of things. Since the original paper was 16 pages long, there's no way I can summarize it all today, so I'll be narrowing the focus a bit. The British Empire's relentless commercialization of opium tainted its relations with China, igniting two wars and leading the once proud Qing dynasty to ruin. In order to understand how the opium trade funded one major world power's rise at the expense of another, we must turn our attention to the interconnected economic relationships between the tea, silver, and opium markets. By the late 19th century, the British were completely obsessed with tea. It became an integral part of the British identity. British subjects from all over the world adopted tea drinking into their common culture. As the most imported product in the empire's trading account, the import duties on tea comprised nearly 10% of the British economy's entire revenue, and the best quality tea was grown in China. However, British merchants had a problem. The Chinese refused to trade for British products. They believed that foreign goods were inferior to the ones they produced domestically, and they were also wary of interacting too much with who they labeled as outside barbarians. As a result, the Chinese were more than willing to sell their tea, but only in exchange for silver, which they could use to invest in domestic capital and strengthen their own economy. This resulted in a crippling trade imbalance. The treasury in London was being depleted at an alarming rate. As the silver supply dwindled, British merchants became unable to import enough tea to satisfy the ever-growing demand. The trade deficit between the two countries began to erode the British economy, undermining its other markets and draining it of capital. Meanwhile, the Chinese were struggling with their own, much more sinister addiction. Originally, opium had only been used in China for medicinal purposes in the form of large, concentrated pills. This changed when Western merchants made their first contact with China and introduced one of Europe's unique customs to Chinese society: smoking. While the Western custom was to smoke tobacco, the Chinese soon discovered that opium could be smoked as well, with powerful, mind-altering effects. The drug's grip on China became stronger as opium dens sprang up across the country. The addiction was not confined to any one group in Chinese society. People from all walks of life were ensnared by the habit, even the emperor himself. Opium began eating away at the fabric of Chinese society. Despite the Qing government's efforts to ban the drug, the black market opium trade was flourishing thanks to foreign merchants and smugglers. Corruption ran rampant. Chinese officials accepted bribes of either money or opium to turn a blind eye to those importing contraband, and as a result, the drug continued to flow freely into the Qing Empire. Exasperated by the continued influx of opium, the imperial court restricted foreign commerce. The aim of the new commercial policy, known as the Canton system, was to isolate foreign imports to the southern port city of Canton. By bottlenecking the flow of opium, the Chinese government hoped to stifle it once and for all. Chinese consumers discovered that the opium produced in British-controlled India was far more potent than what was being produced elsewhere. Demand for British opium rose in spite of the imperial ban. British merchants in Canton were overjoyed. Here, finally, was something the Chinese were willing to trade for. So the Canton region became the epicenter of the opium trade in China. The British had found a solution for their silver shortage. They would simply trade one addiction for another. Opium was lightweight, small, and easy to transport in mass quantities. It was cheap to produce and worth far more than its weight in gold, making it more lucrative to transport than heavier goods. It would become the new medium of exchange that enabled them to purchase Chinese tea. The East India Company recognized the opium market's potential for netting massive profits. So they converted several of their cotton plantations in the northeastern regions of India into poppy fields. Now, I could go off on a long tangent about the complicated process of turning a field full of flowers into a potent hallucinogenic drug, but I only have 3 more minutes to talk, so we're just going to skip that bit. The fact that the drug was illegal in China complicated matters. Since the British Empire couldn't directly import opium into the country, they devised an alternative method to subvert the Canton system. Once a batch of opium was ready to sell, the East India Company packed it into crates and sent it to auction houses in major trade hubs like Calcutta and Bombay, where private British merchants bound for China would bid on them. These merchants would take that opium to Lin Tin Island, just off the coast of Canton. This was a rendezvous point for local smugglers, who traded in credit tokens, which functioned like modern checks. While the smugglers distributed the drug to local dealers, bribing port authorities with a cut of their cargo, the British merchants proceeded to Canton, where they would exchange the tokens at credit houses for Chinese silver. Now, they could use this silver to purchase Chinese tea, which they then brought back home to British ports. The imported tea was taxed and then entered British markets for consumption. Through this elaborate process, the British Empire gradually reversed its trade deficit. Soon, the Qing Empire faced deteriorating economic conditions, as silver and tea flowed out of the country as quickly as opium flooded in. The opium trade eventually became a catalyst for conflict. In 1839, the Qing imperial court redoubled its efforts to crush the trade. Their methods became increasingly aggressive, raiding opium dens, imposing harsh penalties on those caught with contraband, and even seizing and destroying foreign merchants' cargo. Their aggressive actions provoked a reprisal from the British Empire, triggering the First Opium War. The war lasted for 3 years, resulting in roughly 500 British casualties and nearly 20,000 Chinese casualties. The Qing Empire was forced to grant extraterritoriality to British merchants, that is, exemption from Chinese laws while on Chinese soil, and to open 5 other ports to foreign trade. They also had to cede the island of Hong Kong to the British. Lingering resentment and the Western powers' desire to unlock further commercial privileges with China led to the outbreak of a second Opium War in 1856, which lasted 4 years and was much more devastating to the Chinese than the first. It was after this defeat that the Qing imperial court was forced to formally legalize the opium trade and make even more humiliating concessions to the Western powers. The legacy of the British opium trade has been decidedly dark. The British Empire prospered as a result of its success, using the profits to fund expansion in the late 19th century. However, China limped into the 20th century in severe economic distress and with its people facing extreme dependency. By 1906, 23.3% of the adult male Chinese population was addicted to opium. The country suddenly found itself deprived of silver, which left little capital to invest in domestic production. Since the Chinese, as a rule, relied on domestic products rather than foreign imports, this lack of capital was particularly devastating to their economy. In addition, the Opium Wars had opened China to a troubling trend of exploitation at the hands of Western imperialism. And here are my references. Thank you guys so much for listening to my presentation. I'd like to once again thank my advisors, Dr. Wallace and Dr. Tenace, as well as Dr. Buby, for their guidance on this project. And if anyone has any questions, I'll be happy to take them. Hey, everyone.
So yeah, hey guys. I guess just reflecting on this, like I said at the beginning of the video, the original research paper was a 16-page document, and so there was a lot of information that I really couldn't include in this presentation. Like the events leading up to the outbreak of the First Opium War, that could fill an entire Pecha Kucha in and of itself. And really, I wish I could have talked more about the legacy and how the opium trade impacted Chinese society and like the tensions that erupted between the East and West in its wake. And so there was a lot that I couldn't get to, and that I regret. But I am happy with the result. I learned a lot about public scholarship through this process. I learned a lot about communicating my ideas effectively, and I had a really fun time throwing this together.
All right.
Kristen, could you tell us just a little bit about the legacy of the Opium War and like current events and current diplomacy, perhaps?
My research doesn't get into super modern stuff. I talked in my research a bit about tracing the legacy through the 20th century and how the opium wars have been viewed both in China and in the West differently. Whereas in the West, you know, it barely graces our high school classrooms. In China, it's kind of this launching point for the century of humiliation is what it's is known as. And so there's this whole legacy of basically society regressing that the Chinese have blamed on European intervention and interference in the 19th century in Chinese affairs. And so if we follow that, we can see that a lot of the hostility that the East had for the West in the mid 20th century could stem from these events. And there were other factors as well, but that was a major part of it. And then there's also Hong Kong, you know, all of the controversy and stuff going on in Hong Kong. A lot of that stems from the influences of the opium trade, and the fact that Hong Kong was ceded to the British at all was because of the first Opium War. So you can, there's a very long and troubled history between China and the West, and a lot of it stems from this opium trade.
Great. I didn't expect there to be so much about drug use in this this evening's discussions. That was kind of fortuitous, I guess. Dr. Bill, do you have anything you wanted to add, or you want me to say a few things first? Okay. So I just want to say a couple of final things. First, wow. I'm just amazed at what you all did tonight and last week. The quality of your Pechacucha presentations. I know that many of you wanted to do things a little bit better, but I really was very impressed. And I think a lot of us who were not members of the class itself would agree. I learned a lot about your fields. I had the privilege, of course, of getting to talk with each of you individually and with your advisor. And it was, for me, a very challenging and great experience. And I think this all shows the power of the liberal arts education and how it can have a lot of impact on public scholarship when it's done effectively, as you all did it. And I liked the sophistication and, in many cases, the humor. A lot of puns over the last 2 weeks, and that usually makes me happy. So you're all very amazing. And I hope you, as you pursue your specialties in the future, that you don't forget that public scholarship is an important thing to bring to the world in a time when scholars seem to be distrusted. Second, I'm also reminded that the first time I met most of you in the class was the first semester of your freshman year at a pizza party in Whiteside Hall. And at that time, I was serving as interim provost. Most of you were a little bit shyer then than you are now, but it was obvious even then that you guys were a very smart and eager to learn group that were set on excelling. And I think what I've seen tonight and last night and throughout this entire capstone seminar bears that out. Working with you has been a privilege and a great joy. This was the highlight of my semester, without a doubt. So I want to thank Dr. Beal for inviting me to be the first teacher for this seminar. I don't feel like I really did much teaching as much as getting you all together to do your thing. And I want to thank all of you seniors that are graduating this year. You guys are really awesome, and I hope you continue to contribute a lot to society. So thanks very much.
I'm going to add to that real quick. I know it's a late night and it's last week of class and there's like stress galore. So I don't want to drag it out. But I want to say couple of like quick closing statements, 2 reminders, and then some kind of summative stuff. First, please remember to do your course evals for Professor Buby and for all your faculty. But this is a weird course, and the first running of it, and we need, constructive feedback, which I'm sure you're capable of giving if you'll just take the time to do that. Please also thank your faculty advisors, several of whom are on the call now. Professor Dodd shepherded some, 24 projects through the senior capstone. I see Professor Hollinsworth, Jones, Professor Crosby, others. Please make sure that you send these folks a note to say thanks for their time, because this is a little bit extra they've done for you all. So a quick note to seniors, and then one to like everybody on the call. Seniors, like not a one of these things was like substandard in any way. So I'm super proud of your work. Not surprised, but super proud. I want to say to like the seniors and to those of you who are like watching, kind of looking ahead toward your senior capstones, maybe hard. I know I'm just going to kind of echo what Professor Buby has said. Maybe kind of hard to see the importance of this public intellectual stuff when you go to college to major in something, and we're asking you to be kind of parallel to that for this class. It is still critically important, and I hope that you guys have gotten some of the skills to begin bridging that gap between the public and our kind of like insulated academy, because that's not, the longer and further we drive a chasm between these kind of organizations, the harder things are going to get down the road. I also hope that in the course of y'all's constructing some public engagement, you might also begin to decode a little bit how other people's public engagement works. I'm thinking, for instance, of the YouTube channel called ContraPoints, which I watch sometimes. I don't know if you guys are familiar with this one. It's a sex and gender deal. Very stylishly drafted. And sometimes I would say it's quality material, but sometimes the argument weighs on the editing and not maybe the argument itself. And so I'm not accusing anybody here of doing that, because I know no one here would have been up to any funny business or cheap tricks, but we can see that going on around us. And you might be more attuned to the pull of it. Seniors, when you guys go off into graduate school, law school, med school, the workforce, those places are probably not going to put a very high premium on doing public engagement. That's my guess. Hollinsworth is shaking his head like, yeah, they do, or no, they do not. Not in your field, not in my field either. I hope in some measure you'll carry this with you, even if your, further curricula and your later advisors and faculty maybe don't make it a high priority, because we all need to start working on bridging this gap, what this course is kind of devised to do. I'll kick it back to you, Professor Buby, to close however you like. But thank you again for all your hard work, guys.
Okay, I know. Thank you for staying here for the full length of this. This went over a lot longer than I expected it to this evening. But again, thank all of you, and see you around. Take care. Yeah.